Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is set 3 of 5 good problems on the topic of area of polygons, where I will solve 5 relatively hard problems on the topic of area of polygons, that is area of triangles, rectangles, rhombus, trapezium, and regular and irregular polygons. If you have not watched the previous 2 sets of 5 good problems, then I strongly suggest and request that you also watch those videos. This video is part of the playlist Maths 8 Hot. HOT, Hot stands for High Order Thinking, where I come up with relatively 5 harder problems and solve them. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel. And also do not forget to press the bell icon so that you will be notified by my future videos. Okay, so let's get started in solving 5 good problems of set 3 on the topic of area of polygons. Okay, so I have the set of 5 good problems on the left hand side. I hope the fonts are big enough so that you can read them. The link of the PDF of this set of 5 good problems will also be there in the description below. On the right hand side, I will solve the problems. I will pause for a few seconds after solving a problem so that you can take screenshot of the solution if you think it will help you. Always try to solve these problems yourself first. Ideally, you should be able to solve these 5 problems in 30 minutes, taking 6 minutes per problem. Only when if you are stuck or if you want to see my way of solution, you please watch this my solution. And please note that there is no a single way of solving a mathematical problem. There could be multiple ways. If you have a better way of solving it, that is fine, totally fine. Please stick to the method which is more comfortable to you and which is more understandable to you. And always remember, after solving a set of problems, always revise the key concepts and formulas that you applied in solving the problem. I initially intended to do that myself at the end of every video, but I thought it will make the video unnecessarily longer, so I will not be doing that. But please do that yourself every time you solve any good questions, whether it be test or from exercise book, from exercise problems of the test book or any other reference book or any competitive question paper. Always do this. This will always help you to remember things for a longer time. Okay, so let's start solving the problems. 1 second, friend. I just okay. So the first problem says that an isosceles trapezium has an area of 140 a square and an altitude of 10a. Question number 1. And an altitude of 10a. If the longer parallel side is 12a more than the shorter parallel side, then the perimeter of the trapezium is. Okay, I think it should be a straightforward question because, okay, so area of trapezium we know is equal to half multiplied by the sum of the parallel sides. Let's say I always denote x and y as the length of the parallel sides, x being the shorter parallel side and y being the longer parallel side. So x plus y, sum of the parallel sides, multiplied by the altitude or height of the trapezium, which is perpendicular distance between the parallel sides. I denote that by h. So this is the area of a trapezium. Okay, so this is given to be 140 a square. Now this implies the altitude is also given. So we have half into x plus y. The altitude is given as 10a. 10a is equal to 140 a square. So we will get the sum of the parallel sides. So this implies x plus y, which is the sum of the parallel sides, will be equal to 2 by 10a multiplied by 140 a square. This after simplification is how much it is? 28a. Now I am prone to make calculation mistake, but even though I will try my best not to make calculation mistake, but eventually I might end up doing calculation mistake. Okay, so 28a is the sum of the parallel side. Okay, now it is given that the longer parallel side is 12a more than the shorter parallel side. So we also have y minus x. As per my convention, I always denote y as the longer parallel side. So this is given as 12a. Okay, this is given as 12a. Fine. It is asking finally the perimeter of the trapezium. Now what will be the perimeter of the trapezium? Perimeter, it is an isosceles trapezium. So perimeter P will be the sum of the parallel sides, that is x plus y, that is the sum of all the sides. So sum of the parallel sides plus the sum of the two equal sides. So if the two equal sides is let's say d, we will have plus 2d. So let me just for the sake of reference, this be the isosceles trapezium x, y, and we have d and d. We have to find the perimeter. We already know x plus y, which is 28a. Now y minus x is given, that is 12a, and we need d, we need t, we need d. Okay, so we need t. Okay, so I discussed one formula that relates the length of the non-parallel equal side and the altitude as well as the parallel side. That is basically the difference of the parallel sides. So if you if you wish, you can see my theoretical video on how to find area of isosceles trapezium in the other playlist, that is CBSE Maths 8 or Agarwal. So the formula was that the altitude of a isosceles trapezium h square is equal to d square. D is the length of each non-parallel equal side minus y minus x by 2 whole square. So there is a relation between the altitude, the length of the actually y minus x is the difference of the parallel side, and the d, which is the length of equal non-parallel side. Okay. So applying this relation or formula, h is given, altitude is given to be 10a, so I can have 10a. The idea is to find d. I have to find d. So from this equation I can find d, because y minus x is known, it is given, and I also know h. So I have 10a square is equal to d square minus what is y minus x. Y minus x is given to be 12a by 2 square. Okay, so this implies 100 a square is equal to d square minus what is 12a by 2 is 6a, and so this is 36a square, 36a square. Now the formula, if I am wondering whether the formula was h square equal to d square minus, okay, so the concept is that if I, let's say if I draw a perpendicular from this vertex to this on this side, so this will be h, height, and this part, the base of this triangle will be y minus x by 2, and so from the Pythagoras theorem we will have d square is equal to, we will have d square is equal to h square plus y minus x by 2 whole square. That is fine. So we have a 10a square, d square, 12a by 2, 6a 36 square. So this implies, I think we have d square is equal to 136a square. I think I did some mistake in giving the So I framed this question. I think I incorrectly given the wrong data, because I was thinking D will come out to be D will not have any roots, but over here, if we the square root of 136 is 136 is not a perfect square, so this will imply that D is equal to A and square root of 136, and 136 is definitely not a perfect square. So I was not expecting this, so I might have done something wrong in giving the data properly. But anyway, let's solve the problem, whatever data is given. So definitely the answer will not match with any choices. I'm really sorry for this. Quite frequently it happens with me, because most of the problems I design myself, taking reference from other book or any other question, and in framing the question I make mistake. So I'm really sorry. I'm really sorry. I'm really very sorry for this. But please focus in the concept of the problem, and even if your answer, even if I give some wrong data in the problem, please don't be worried. Try to see that you have understood the problem and you have applied the concept properly. Okay, so now what will I do with root over 136? Okay, so is it okay, so this is 4 multiplied by 34, I guess. Okay, so this is 34, 17 into 2. Okay, so this is kind of 2a root 34, very weird figure, but anyway, so D is this, fine. So D is this. So the idea is, now this will imply perimeter will be equal to x plus y plus twice of D. X plus y we have already found to be 28a, and twice of D will be 4a root over 34. While I was designing the problem, I had in my mind that D will come out to be 8a. 8a. So 28a and twice of D will be 16a. So it will be 44a. Anyway, so perimeter is 28a plus 4a root 3. Definitely it will not match with any of the given choices, as I gave the data, that is all these values 12a, 10a, 140a square incorrectly. Sorry for that. Okay. The idea was to how to find the D, that is the length of each equal non-parallel side from the given information. First you have to find x plus y, which we can easily find if the area of a trapezium is given and the sum of the parallel and the altitude is given. We can easily find x plus y, that is the sum of the parallel side. Then the next task was to find the D, that is the length of each equal non-parallel side, and we have this relation. Using this relation, we know that the height of the isosceles trapezium, the length of which is h, and D is the length of the each non-parallel equal side, and y minus x is the difference of the parallel side. This is the equation, how they are related. From here we can easily find D if we know h and y minus x. This was the concept applied. Okay, let's see the next problem. ABC is an isosceles triangle where AB is equal to AC. ABC is an isosceles triangle where AB is equal to AC. A line segment EF is drawn parallel to BC. This is an isosceles triangle where AB is equal to AC. A line segment EF is drawn parallel to BC so that ratio of area of triangle AEF and quadrilateral EFCB is 1:m. Then the ratio AE is to AB is. then the ratio AE is to AB is. Okay, we can see that if there is a perpendicular drawn AH on BC, no information is given about AH. Okay, ratio of area of triangle AEF, triangle AEF. Okay, let me quickly draw the figure. We have an isosceles triangle A, B, C, where EF is some line segment parallel to BC, and we have these two angles equal, that is AB is equal to AC, AB is equal to AC. Okay, this is an isosceles trapezium, triangle. AB is equal to AC. Okay, so that the ratio of area of triangle AEF, it is given that area of triangle AEF and divided by area by AR, I mean the area of EFCB is given to be 1:m, that is 1 by m. This we know. Then the ratio AE is to AB, AE is to AB. We have to relate AE is to AB. Since it is talking about area, since it is an isosceles triangle ABC, if I drop a perpendicular, that is why the hint is given in the figure. If AH is perpendicular to BC, we know one property is that if you drop if in a triangle ABC angle B is equal to angle C, and if you drop a perpendicular from A to BC, then the perpendicular AH will bisect BC, that is BH will be equal to BC, BH will be equal to HC. Okay, BH will be equal to HC. BH will be equal to HC, or we can say that, the triangle it is talking about is AEF. Now, please note that let's say the perpendicular AH and EF bisect at the point G, not bisect but intersect at the point G. So, what is the area of triangle AEF? Area of triangle AEF is half into altitude AG into base EF, okay. And what is the area of triangle? Area of triangle okay, what is the area of EFCB? We can think of the area of EFCB as the difference of the area of triangle ABC and the area of triangle AEF. Okay, so what is the area of triangle ABC? It will be half AH multiplied by BC. No dimension is given. Okay, a half AH multiplied by BC. AH. Now, one concept is there regarding a triangle is that if you have any triangle, it can be any triangle, let's say XYZ, and if you draw a line parallel to the side YZ anywhere, let's say over here, let's say this be PQ, the PQ is line parallel to YZ. XYZ is any triangle, you are drawing a PQ is parallel to YZ, then we will have a ratio, that is the triangle XPQ and XYZ, they will be similar, they will not be congruent, they will be similar, means they will look same but they are of different size. And also we will have XP and the sides will be proportional, that is XP by XY will be equal to PQ by YZ will be equal to XQ by XZ. This one concept you must always be aware of. Okay, so we have to find the ratio of AE is to AB. AE is to AB. AE is to AB. Let's triangle AEF is half AG into EF, AG into EF, and the triangle ABC is area half AH into BC. Now there is must be a relation between AG and AH. Also you see that so this concept that I have mentioned for the triangle XYZ and the PQ parallel to YZ, we will have the corresponding sides equal, that is the ratio will be equal, that is XP by YZ is equal to PQ by YZ is equal to XQ by XZ. This concept I can apply in the triangle ABH. For triangle AG and AH, for triangle AEG and the triangle ABH, applying the same concept, I can say that AE, since EF is parallel to BC, we will also have EG is parallel to BH. So we will have AE by AB will be equal to EG by BH will be equal to AG by AH. And finally we have to find what is the ratio AE is to AB. So let's say this be some ratio x, or let's say not x, but since this ratio, all these ratio are same, let's consider this to be equal to k. Okay, and finally we have to find k. Okay, now so what is so this implies that what is AG? AG is equal to k into AH. AG is equal to k into AH. And what is EF? And what is EF? Note that EF will be, if I consider the triangle AEF and the triangle ABC, for triangle AEF, applying the same ratio concept and triangle ABC, I will have EF I will have mm, uh, uh, EF, I will have EF by BC will be equal to EF by BC will be equal to AE by AB, and AE by AB we already as per our previous assumption is equal to K, is equal to K. Okay. So this implies that EF will be equal to K into BC, will be equal to K into BC. Okay. Now AG is equal to K into AH and EF is equal to K into BC, where K is the ratio, basically K is the ratio of AE to AB, and this K we have to finally find. Now then area of triangle AEF, is equal to half what is AG? AG is KH, so K into AH multiplied by EF. What is EF? K into BC, K into BC, which is equal to K square by 2 AH multiplied by BC. This is the area of triangle AEF, and the area of triangle ABC is half AH into BC, half AH into BC. So therefore, what is the area of the quadrilateral EFCB? EFCB is nothing but area of triangle, the bigger triangle ABC, minus the area of triangle AEF. This is equal to, what is area of triangle ABC? It is half AH into BC. And what is area of triangle AEF? It is K square by 2 multiplied by AH into BC. Okay, if I simplify, if I take AH and BH, if I take AH multiplied by BC by 2 common, I have 1 minus K square. So this is the area of the quadrilateral EFCB. Therefore, what is the ratio of the ratio of triangle AEF and the area of the quadrilateral EFCB? This is equal to, what was the area of triangle AEF? It was K square by 2. It was K square by 2 multiplied by AH into BC. And what is the area of quadrilateral EFCB? It is AH multiplied by BC by 2 multiplied by 1 minus K square. So if you simplify this, we can see that AH multiplied by BC by 2 will get cancelled out, and this will become K square by 1 minus K square. Okay, so this is the ratio. So this implies the ratio is already given to be 1:m. So we must have K square by 1 minus K square is equal to 1 by m. So from here we have to find what is K square or K. So you can consider K square as a unknown variable, and this is a linear equation. This is the linear equation in K square, not K but K square. So if I do cross multiplication, I have K square m is equal to 1 minus K square. This implies K square m plus K square is equal to 1. This implies that if I take K square common from the left hand side, I have this. So this implies K square is equal to 1 by 1 plus m, and hence K is equal to square root of 1 by 1 plus m. So, and what is K? K was the ratio A is to AB, we assume that the ratio A is to AB is equal to K. Okay. So the correct choice should be, now what is this? This is nothing but square root of 1 divided by square root of 1 plus m, which is nothing but 1 by square root of 1 plus m. So the correct choice is answer A. A is the correct choice. Okay, let's do the next problem. Question number 3. A regular hexagon has a side length of b centimeter. If the area of the hexagon is a centimeter square, then the value of b square is. Side length of a regular hexagon is given, its area is given to be a centimeter square, then the value of b square is. Now, so a regular hexagon meaning 1, 2, 3. What will be a regular hexagon? 1, 2, 3, 4. Okay, so it will be something like this. My diagram will not be perfect, but I'm trying as best as I can. So this is a regular hexagon. A, B, C, D, E, F. That is, all the sides are of equal length. Each side is given as B. The length of each side of the regular hexagon is B centimeter. The area is given as A centimeter square, capital A. We have to find the value of B square. Now, one concept is that how do we find the area of a regular polygon? Please note one thing, that the center of the polygon of any regular polygon, something like over here, this is the center of this regular hexagon. This center, let's say the center be O. This center will create isosceles triangle with all the sides. That is, if you connect all the vertices of the regular polygon, my diagram will not be look good, but anyway, if you connect, if you create triangles with the base, with all the sides, not base, but with all the sides of the regular polygon, you will see all these triangles, they will be congruent and they will be isosceles. They will be isosceles. That is, these two sides, these sides will be equal. These sides will be equal for all these triangles. All these triangles will be congruent and they will be isosceles, where we will have OF for triangle. I am considering, just for an example, consider the triangle OFE. OFE, we will have OF equal to OE. In general, for any regular polygon of n sides, the center of the polygon will create isosceles triangles with all the sides, and all these triangles will be congruent. And in the isosceles triangle, or in all the isosceles triangles, the two sides apart from the side of the regular polygon, they will be equal. So we have OF is equal to OE. Now in this particular case, now consider in this particular case, so if OF is equal to OE, then these two angles must be equal. These two angles must be equal. Okay. Now, for this particular regular polygon, which is hexagon, you see that the sum of all the angles, around the point O is 360 degree. So all this angle, let's say this angle be x degree, all this angle x, this will also be x, this will also be x degree, this will also be x degree. All these angles, this x degree will be definitely equal to 360 degree divided by hexagon. That is, there are how many triangles are formed? As many number of sides. So there are hexagon 6 sides. So 6. So this will be 60 degree. So all these angles x degree will be 60 degree. So if x is 60 degree, and also so in triangle OFE we have angle FOE is equal to 60 degree, and also we are having angle OFE is equal to angle OEF. If you do a little bit of mathematics, it will clearly indicate that the other two angles, that is, it will clearly indicate that triangle OFE is equilateral. Because the sum of the angles of a triangle is 180 degree. So the sum of the angles of OFE plus OEF will be equal to 180 minus 60, which is 120, and they are equal. So each angle must be 60 degree. So for a regular hexagon, all these triangles are equilateral triangle. Okay. Now we have to find the value of b square. So somehow from b, that is the length of the side b, and the fact that it is a regular hexagon, we can easily find the area of this entire regular hexagon. How? The area for this regular hexagon, that is A, B, C, D, E and F, will be equal to all the area of this. There are 6 congruent triangles. So 6. So the area will be the area of the sum of the area of these 6 congruent triangles, which will be 6 times the area of each triangle. Now each of these triangles are equilateral triangles having side as B, because this is B. So this will be B, this will be B. And you know that the area of an equilateral triangle having side length of A is root over 3 by 4 A square. So in each of the area of each of these congruent triangles will be root over 3 by 4 B square. Okay. So this is equal to given as A. So now we have, if we simplify a little bit, the left hand side we have 3 root over 3 B square by 2 is equal to A. This implies B square is equal to twice of A divided by 3 root 3. So the correct answer is choice D. Always remember that in a regular polygon, all the triangles formed from the center with each side are isosceles triangle, where the angles of each of these isosceles triangles, the two angles that is at either end of the side are equal. And if it's a regular hexagon, then definitely each of these triangles will be equilateral triangle, and all these triangles are congruent and they will have equal area. And of course the area of the regular polygon is sum of these triangles. Okay, let's see question number 4. ABCD is an isosceles trapezium. ABCD is an isosceles trapezium with AD parallel to BC. DCB is equal to 60 degree and ABD is equal to 30 degree. ABD is equal to 30 degree. And AE is parallel to BD. AE is parallel to BD. AE is perpendicular to BD. Sorry, AE is perpendicular to BD. Let me draw the figure. We have an isosceles trapezium. It is an isosceles trapezium. Okay. So this is an isosceles trapezium. This is BD. So this is A, B, C, D. Okay. So AE is perpendicular to AE is perpendicular to BD, and EC is joined. Okay, EC is joined and it is given that this side is A, that is the length of equal non-parallel side is A. So this is also A. This angle is given as 30 degree and angle DCB is 60 degree, DCB. So this whole angle is 60 degree. What else is given? Okay. It is asking find the area of quadrilateral AECD. AECD. If area of triangle DBC, if area of triangle DBC is double the area of triangle ABD, given area of triangle DBC is double the area of triangle ABD. Okay. Then find the area of quadrilateral AECD. We have to find the area of quadrilateral AECD. Okay. Why are the angles given? Okay. So this is an isosceles trapezium. So this angle is 60 degree. Means remember that in an isosceles trapezium, always remember that these two angles are equal, and also these two angles are equal. That is the angles at the end of each parallel sides are equal. Okay. So DCB is 60 degree. So definitely we will have angle ABC must be equal to angle DCB equals to 60 degree. So this implies this angle is ABD is 30 degree. So this, what is ABC? Angle ABD plus angle DBC is equal to 60 degree. So this implies angle ABD is given to be 30 degree. 30 degree plus angle DBC is equal to 60 degree. So this implies angle DBC is equal to 60 degree minus 30 degree, which is 30 degree. Angle DBC. So this is also 30 degree. Angle DBC. So this means, this implies that now what will be angle BDC? BDC will then be equal to 180 degree. Since in a triangle all the sum of the angles are sum of the angles in a triangle is 180 degree, then angle BDC will be equal to 180 degree minus 30 degree minus 60 degree, which is coming out to be 90 degree. Okay. So this BD must be perpendicular to DC. So this implies BD is perpendicular to DC. BD is perpendicular to DC. BD is perpendicular to DC. Okay. And we also have AE perpendicular to BD. So this implies that if BD is perpendicular to DC and A is perpendicular to BC, this will imply that DC must be parallel to AE. DC must be parallel to AE. Okay. DC is parallel to AE. We have to find the area of quadrilateral AECD. So we can clearly see that AECD is a trapezium. So this will imply that AECD is a trapezium. With AE parallel to CD, and we can also see that height of this trapezium is equal to will be ED, since ED is perpendicular to both AE and DC. So height must be ED. Okay, so how do we know AE, DC and ED? Because we have to find the area of quadrilateral A. Now the quadrilateral AECD is basically a trapezium. We have to find the area of AECD. So we need to know the parallel sides and the height. That is, we need to know AE and CD and ED. We are only okay. The options are all based on A. What is A? A is this length of unequal equal non-parallel side. Mm, area of DBC is twice of area ABD. What is area of DBC? What is area of DBC? Mm, area of triangle DBC we can think of as half into base. We can consider base as DC and height as BD, that is the diagonal. This is equal to BD. DC is given as A, BD A by 2. Okay. Okay. And we have to utilize the fact that area of triangle DBC is double the area of triangle ABD. Now let's find what is the area of triangle ABD. ABD will be equal to we can use the you can use the BD as base and AE as the height. Half into AE into BD into BD. Okay. This implies it is given that area of a DBC is equal to twice of area of ABD. So this means that BD multiplied by A by 2 is equal to twice of half multiplied by AE multiplied by BD. So BD will cancel from both sides. So we can see we are getting AE in terms of A. So what is AE will be? AE will be half of BD by 2 cancels out. BD by 2 cancels from, then AE will be A by 2. AE will be half BD cancels out. Yes, AE is A by 2. AE is A by 2. We got AE. We also know DC. We know DC. To find the area of the trapezium AECD, we need AE, which we have got. We have found to be A by 2. DC we already know to be A. Now we need to know ED. ED. How do we know ED? We know BD. How do we know ED? How do we know ED? We know AE. Okay, so we can find BE. We can find BE from the right angle triangle ABE. Okay. In triangle ABE, we see using Pythagoras theorem AB square will be equal to AE square plus BE square. AE square plus BE square. This implies what is AB square? What is AB? AB is also A. So A square. AE is A by 2. So this will be A square by 4 plus BE square. So we will get BE square is equal to A square minus A square by 4, which is 3A square by 4. So this will imply what is BE? BE is root 3 by 2A. We have found BE. We know BD. What was BD? BD is, what is BD? Do we know BD? AE is A by 2. Do mm, uh, BD AE is A by 2, AE is A by 2, so BE is root 3 by 2A. We got BE. Hmm, how do we know ED? Uh, we know A. Uh, we don't know AD and BC. Okay. Hmm, AE we have found. We have to find ED. We have to find ED. DC. Okay, DC is A. That is fine. DC is A. AE we know. We have to find ED. We have found BE. Can we know what is BD? How do we know BD? How do we know BD? BDC is a right angle triangle. That is fine. Uh, we don't know BC. Fine. Mm, ED. Uh, BE we have found. Is there any way to find BD? This is an 60 degree. This is right angle triangle. Mm, DC is A. AE, DC. ED. We need to know BD, only then we can find ED, because ED will be BD minus BE. We have already found what is BE. Find the area of quadrilateral for AECD. AECD. ED. How can we find BD? How can we find BD? degree A B. BD. BD. Is BE equal to EB? No. BE. BD. Without knowing BD, how can I find ED? I need ED. Sorry friend, I will skip this question for the time being. I will move on to the next question. I'm keeping some space. Let's do, this was question number 4. Okay, let's do question number 5, the last one. ABCD is a square field of side length A. ABCD is a square field of side length A and surrounded outside and inside by roads of uniform width of X and Y respectively. Okay, so ABCD is the square field, and outside it there is a road surrounding the field outside has a uniform width of X, and the road inside the inside the square field also is surrounded by another road of width Y. If ratio of area of sections EHDA and JLCD EHDA and JLCD is 1:1, then A equals. Okay, so there is a square field. And the length of each side is A. Okay, so there is a road surrounding the field ABCD BCD of uniform width of X. So let's say it will be like something like this. This is the road outside surrounding the square field. So all these are X. So these are the width of the road outside the surrounding outside the field is X. These are all X. Okay, and there is a road inside of uniform width of Y. So let's say this be the road inside, that is this. So okay, now it is the points are given as E, H, G, and this is F, E, F, G, H. Okay, and this is I, J, K and L. It is asking to find the ratio of the area of EHDA. Okay, so EHDA. Now please note that EHDA will be a trapezium, since obviously these two are parallel. These two are parallel. It will be a trapezium, and the so this is the section EHDA. This is a trapezium. Also the other section, which is JLCD. So this one, JLCD, this will also be a trapezium where JL is parallel to DC. It is asking to find if the ratio of these two area of these two section is 1:1. It is asking to find what is A. So basically we have to first find the area of the two trapezium. So area of trapezium EHDA will be equal to half multiplied by the sum of the parallel side, that is EH plus DA, multiplied by the height of this trapezium EHDA. You can clearly see that the height will be the width of the road outside the the width of the road which is surrounding outside the square field, which is x. So this will be x. We have to somehow find what is EH and DA. Also the area of trapezium JLCD will be equal to half multiplied by the sum of the parallel side, which is JL plus CD, multiplied by the height. As you can see, the height of this trapezium will be the width of the road that is surrounding the field inside, which is y. Now let's find. We have to find EH and DA. Okay, what is EH? EH is nothing but, we have the square field of length. The square field has the side length of square field is A, and so and outside it the road has a uniform width of x. So EH will be nothing but A plus x plus x. Why 2x? Because on the left hand side there will be a road, and also on the right hand side there will be the road. So EH, this entire thing will be, on the left hand side we have road of width x, and then the square field, and then again x. So this is equal to A plus twice x. And what will be AD? AD is nothing but the side of the square field, which is A. Okay. Similarly, what will be DC? DC is A because it is the side of the square field A. And what will be JL? JL will be equal to A minus y minus y. This is A minus twice of y, because the width of the road inside the square field is y. Okay. So now what is area of trapezium EHDA? It becomes half into what is EH? EH is A plus 2x, and what is DA? DA or AD is A, and we have x. This is equal to, after simplification, A plus 2x plus 2A will be 2x plus 2A. If we take 2 common factor out, it will be A plus x and x by 2. This is x into A plus x. This is the area of the trapezium EHDA. And what will be the area of trapezium JLCD? It is half multiplied by what is JL? JL is a minus 2y plus CD. What is CD? CD is a, and we have y. This is equal to a minus 2y plus a is 2a minus 2y. If we take 2 common out, factor out, we will have a minus y multiplied by y. This is y multiplied by a minus y. Okay, so we have found the area of these two sections in terms of ax and y. Now it is given that these two areas are equal. The ratio is given as 1:1, means that the areas are equal. So this will imply that x into a plus x is equal to y into a minus y. Clearly this we can find from here a. Simplifying both the sides, we have xa plus xa square is equal to ya minus y square. This implies if I bring the x terms, if I bring the a terms to the right hand side and every other terms to the left hand side, I get xa square plus y square is equal to ya minus xa. This implies xa square plus y square is equal to, if I take a common from the right hand side, I get a multiplied by y minus x. So this implies now a is equal to x square plus y square divided by y minus x. So this is should be a, and the correct choice is D. D is the correct choice. D is the correct choice. Okay, let me come back to the previous question that I was stuck. I couldn't solve it. Okay. Find the area of the quadrilateral AECD. So I am stuck in finding the length of ED. So AECD is found to be an is found to be a trapezium where AE is parallel to DC. We know DC, which is already given. We know AE is equal to a by 2. And ED is the height of this trapezium. We need to find ED. We have found BE. We have found somehow BE in terms of A. Now, how do we know ED? If we somehow can find BD, then we can find ED, because BD minus BE will be ED. BD. How we know BD? What is BD? What is the area of triangle ABD? Triangle ABD is half AE into BD. AE is A by 2. BD we don't know. Okay. We know AE, AD. Even though AED is a right angle triangle, we don't know AD. We don't know AD. Isosceles trapezium. $30.90. So these two are parallel. Triangle ABD. BC. BD, BC, we don't know BC. Root 3 by 2. B is root 3a, root 3, okay. Will BE be equal to ED? Is there any way that BE will be equal to BE will be equal to ED? No. I don't know, friend. I'm stuck. I don't know how to solve this problem. Maybe the problem is framed incorrectly. Maybe there are some data missing. I don't know. But I don't see any way how I can find BD. I need to find BD. If I can find BD, then I will know ED, because I've already found what is BE. So we need to know what is BD, and from this, whatever information is given in the problem, at least in my within my capacity and understanding, I don't think how I will find BD, because BDC is a right angle triangle. We know DC. To find BD, we need to know, if we want to apply Pythagoras theorem, we need to know BC. We don't know BC. We know AB, we know BE, and we know AE. BE we know. XY. 6. BD. E and DC. AD parallel to BC. No, I'm sorry, I will leave it here. Sorry, I could not solve question number 4. I will check this out later on, and I will come up with the solution if I can in the next video, in another video if I can. I hope these problems will give you a good practice and good practice of your understanding of the concepts of area of finding area of polygons, that is triangles, that involves triangles, trapezium, regular and irregular polygons. So if this video was beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So I will keep on making 5 good problems on this topic on regular basis. So please keep an eye on this playlist, that is Maths 8 Hot, and also very soon I will start the next chapter, which is 3-dimensional figures, in the other playlist, that is CBSE Maths 8 RS Agarwal. So please stay tuned for these videos to come coming soon. I will end the video here. Thanks for watching, and until the next video, take care and bye.